Welcome to Jelly First School. Our lesson today about the surface area of prism. Please listen and look carefully.
The essential understanding for this lesson is: the surface area of a prism is the sum of the areas of its faces. Previously, students found the areas of two-dimensional shapes, including quadrilaterals and triangles. They also learned how to use a net to represent prisms. In this lesson, students apply what they know about areas and nets of prisms to find the surface areas of prisms. This problem is key because students must use what they know about finding the area of quadrilaterals to find the area of the cardboard piece. Because the piece is a net of a cube, a special kind of rectangular prism, this problem prepares students for finding the area of a net to find the surface area of a prism. Listen and look for students who recognize that the piece of cardboard is the net of a cube. Some of these students may decompose the net into one long rectangle with length 36 inches and width 9 inches, and two squares with side lengths of 9 inches. Next, they find the area of each face. Then they add the areas to get a total area of the net of 486 square inches. Assure these students that they found the correct area of the net or cardboard piece, but encourage them to use a more efficient approach. Point out that since the cardboard piece is the net of a cube, each face or part of the cardboard is the same size square. So the least amount of cardboard needed for each cube-shaped box can be found by multiplying the area of one face by the number of faces. Listen and look for other students who do find the total area of the 6 square faces to solve the problem. They multiply the area of one face, 81 square inches, by the number of faces, 6, to get a total area of 486 square inches. All of these students show an understanding of how to find the total area of a net of a prism. This understanding will help them find the surface area of prisms in the remainder of this lesson.
Okay, now we listen to another video for more understanding.
How can you find the surface area of a prism? Think about this question during the lesson. Kelly wants to cover a shoebox with decorative paper to make a storage box for her photos. How much paper will she need to cover the box? You can use tools to draw a net to help you find the surface area of a solid figure. How might grid paper help you solve this problem? You can use grid paper to draw a net of the shoebox. What type of figure is the shoebox?
Select your answer.
The shoebox is a rectangular prism. How many faces does the shoebox have, and what shape are they?
Okay, a rectangular prism like your room. In your room, how many walls? Yes, 4, and ceiling and floor, so total 6 faces. So when we want to find the area of the total faces, we must find the area for each face. But you note that each two opposite faces are equal in area. So we need to find only 3 faces, then multiply by 2. Okay, like look to the upper face, its dimensions 10 and 8. So its area 10 times 8 equals, yes, 80, because it's a rectangle and the area of rectangle equal length by width. Okay, so the ceiling or the upper face has a similar one in a bottom. Okay, yes, like floor. So the upper face is 80 and the lower face is 80, so we multiply 80 multiplied by 2. Also here, this face, Okay, its dimensions 6 and yes 10. We can find its area and so on. Okay, listen.
The shoebox has 6 faces. The faces are rectangles. Here is one way to solve the problem. Draw a net of the shoebox. Find the area of each face. Then add the areas. Kelly needs 376 square inches of paper to cover the box. Which, if any, of the area calculations are repeated? Explain. There are 3 pairs of repeated calculations because the front and back of the shoebox have the same dimensions, as do the top and bottom and both sides. Here is another way. Use a formula to find the total surface area, SA, of the shoebox. Kelly needs 376 square inches of paper to cover the box. Now you know how you can find the surface area of a prism.
Okay, now we move to the practical part. See you. Hi guys, now the practical part. Open your book, page 715. Our lesson today about the surface area of prism. Okay, this is a cuboid or rectangular prism. Rectangular prism has 6 faces, like your room, 4 walls and ceiling and yes floor. So we have 6 faces. Each face has 2 dimensions. Look to the bottom face here. What is the dimension? 5 and 8. And this shape of rectangle, we can find the area of this rectangle, and this rectangle is the same to the upper one. Okay, now in the side, a rectangle with 6 and 5 dimensions, we can find the area of this rectangle and the opposite one. Okay, now we have this rectangle, its dimensions 8 and yes 6, like this one. So we can find its base, its area and the opposite one. So at first we'll find the area of the first rectangle at the base. 5 times 8 equals 40 centimeter square or square centimeter. The figure number 2 or the rectangle number 2, area equal 5 times 6, yes, equal 30 centimeter square. And the shape number 3, 6 and 8, so 6 times 8 equal 48. Now the total area equal the area of the first one, 40 multiplied by 2, because we have 2 faces with dimensions 5 and 8, plus 30 multiplied by 2 plus 48 multiplied by 2. 40 times 2 equals 80, 2 times 30 equals 60, and 2 times 48 equal 96. Now we add 6 plus 0 plus 0 equals 6, 9 plus 6 equals 15, plus 8 equals 23, and the unit square centimeter. Another problem, we have a triangular prism, triangular because its base is a triangle. So how many faces here? We have a rectangle with dimensions 3 and this is the same, equal 6, so 3 and 6. And we have here a rectangle with dimension 6 and 4, and the last one a big one rectangle, its dimension 6 and 5. Okay, and we have 2 triangles here and here. Its dimensions or its base and height 4 and 3, and they are identical or equal. Now area of triangle, half times base times height, base and height 3 and 4 equal 3 times 4, 12. Half 12 equals 6 square yard. And we have 3 rectangle. Rectangle number 1 and rectangle number 2 and rectangle number 3. Rectangle number 1 here 6 and dimension 6 and 3, so 3 times 6 equals 18 square yard. And the rectangle here is dimension 6 and 4, so 6 times 4 equal 24 square yard. And the third one is big one, 6 and 5, so 6 times 5 equal 30 square yard. Now the total area of polygon equal the area of triangle, but we have two triangles, so 6 times 2 plus the area of each rectangle, 18 plus 24 plus 30. 6 times 2 equal 12 plus 18 plus 24 plus 30, and we add 0 plus 4 4 plus 8 12 plus 2 14, 4 and up 1, 1 plus 3 4 plus 2 6 plus 1 7 plus 1 8, 84 square yard. Okay, the last one, the area of rectangular prism. Here we have 6 faces, the face at the bottom 5 and 10, so the area of the first rectangle 10 times 5 equal 50 square centimeter, and the side one area of the second rectangle 15 times 5 equals 75 square centimeter, and the last one is the opposite one here 10 and 15, so the area of third one equal 10 times 15 equals 150 centimeter square, but the total area equal 50 times 2, because from each one rectangle we have two opposite or two identical, plus 75 times 2 plus 150 times 2. 50 plus by 2 equals 100, plus 75 times 2 equal 150, and 150 times 2 equal 300. So we have 300, 400, 550 square centimeter. Thank you.